Kubernetes is a very vast topic. So it's going to be really hard to show everything in one day. So what I've decided is I'm going to do small bitty lessons every Friday, so that as we along with the progressing weeks, we get to learn more and more about the different functionalities, concepts, and the orchestration methods and the schemas that is allowed by Kubernetes. So let's get started. So the story so far, let's recap what we have all learned so far. So we have all seen that if you have machine learning algorithms, the first step is always to start with the data pipeline. And then you have ML algorithms, using the data that you just scraped out. If it's video or if it's, text data, whatever it may be, you take this data and then you create an ML algorithm from it. And then last week, we started looking into Docker deployments. You also saw code in which you can literally use the Docker file in order to create Docker images. So you saw the differences between a Docker file and a Docker image, and then you always have to build it in order to create a Docker container. So there was always a Docker run and then Docker build, right? But then what next? What comes after? That's what we are trying to address today. So let's try to look at what Kubernetes versus Docker deployments look like. So typically a lot of machine learning engineers, they take their application and they Dockerize it and then they say, that's it, I'm done. We don't need to do any more. What's the need for Kubernetes? So that's why let's look at two use cases that have used either Docker as their endpoint, and then another application that has used Kubernetes as the endpoint. And again, both are equally successful. You'll see both are corporate deployments. You'll see both are equally successful, but you will understand when to use which kind of endpoint deployment. So let's start with Kubernetes. So Kubernetes, the need came for Bose products. We all know about the sound system, the Bose products. So there was a growing need for a huge variety of Bose products that came up. The key issue became scaling across the different product groups. Now, some of the item, the descriptions were similar, but then most of the descriptions were not. So you had a need for constantly updating the product because if newer versions were pushed out, you wanted the customers to know about it. So there was a need to scale across product groups. So that's the reason why the Kubernetes came about as the solution. And it scaled the IoTS PaaS, so platform as a service, on AWS. They used AWS to quickly scale up their deployments and also orchestrate so that if for some reason a Kubernetes container was down, you can spin up a new one instantaneously. What was the result? The result was that the platform now enables 30,000 non-production deployments across dozens of microservices. So in 2018, there were about 1,250 production deployments. So you're able to scale it out. You're able to make sure that everybody globally has access to it. And you can also be able to create versions because your products are getting version controlled very frequently. Now let's look at another use case. So that use Docker. So PayPal, across 200 plus transactions per second. So now PayPal's transaction, if you see, they're very time limited. So it rarely happens that too many applications are paying the server at the same nanosecond, right? So and these applications are very small time intervals. So that's why there is you at one point of time, the amount of service that is happening may not be tremendous. And the services are very quick. So because of this time limitation, a Docker container endpoint is actually pretty suitable for PayPal use cases. The key issue was deployment on a different architecture resulted in maintenance and deployment challenges. So if you think you have a Docker container on a virtual machine in the Americas, and then you have in Asia, and then you have in Europe, the underlying architecture, the underlying OS, if that was different, then maintenance for these deployed containers was becoming hard. And that's the reason why Docker resulted in a uniform delivery system. So rather than using a virtual environment and ensuring the different, if it's Flask or Fast API, or if it's even for machine learning libraries, the exact version, in order to create a snapshot of that, Docker was the best way to unify the systems on all of the servers. And this resulted in PayPal migrated to over 700 plus applications to Docker, over 200,000 plus containers. So you have plenty of containers running everywhere. Every single container will have the exact same version of Python, the exact same version of the sub libraries and everything that you need to pull from. So there will be no issue, scaling across different, different customers at different geographical locations. So that's why you see, if you have a need for continuous versioning, if you have a need for scaling as well as versioning, then Kubernetes is the best way to ensure this orchestration is automated. But if you have very small time interval processes anyway, then in that case, Docker endpoint is suitable enough, right? So now let's get into what is Kubernetes. Kubernetes, just the word itself, it's a Greek word for pilot or helm. That's where it comes from. And Kubernetes is also pretty, commonly known as K8s. So there is a lot of playgrounds, available online where you can actually try your hands on. And these are called the K8 playgrounds. I'll actually show you a demo next week where you can literally go in and spawn up your own virtual cluster and do some playing around in order to get accustomed with the commands and all. So K8s is another name for Kubernetes, and it's an open source system for automatically deploying, scaling, and managing containerized applications. Now that is the key actually. So containerized applications. So you can't really take an IPython notebook or a .py file and put it on Kubernetes. Nowadays, some automations are coming in, so such as mini-KF, and we'll talk about all of this later. But there are a lot of pipelines that are coming up that can literally go from your Python notebook and come up with a pipeline that will deploy things as a Kubernetes container. But ideally, Kubernetes works best with containers. Now, is it only Docker container? The answer is no. If you have some other ways, so like Redis and or your data sets, databases can also be containerized. So if you have any containers, you can actually do orchestration with Kubernetes. So think about Kubernetes as a maestro who is leading this whole musical session, right? So you have this all, think about an orchestra or a symphony. So every single instrument is working independently, and the maestro is actually making sure that in case if somebody misses a beat, or maybe if there's a person who's feeling sick or something, can find a replacement and make sure that the symphony carries on. So that is what Kubernetes does. It ensures that all of these different applications are running in a good way, and it, for some reason, if something is missed, or if a Docker container is down, then ensure that a replica is made so that users should have minimal downtime, right? So the 404 errors or the server cannot be reached should not happen. So that is what Kubernetes is trying to do. Now, Kubernetes started as the successor to the Google's Board project in around the mid 2014. So that's where its inception started. And now let's get into some of the Kubernetes concepts. So the first Kubernetes concept, and is the basic one, as you have to know that there is this idea of clusters. So that means a Kubernetes always comes in a cluster. And you will see when I spawn up a Kubernetes cluster in the live demo today. So a Kubernetes cluster contains of a control panel. So that is the head or the maestro. And the maestro is controlling all these node clusters. And every single node can have multiple pods in it. So pod is the smallest entity in a Kubernetes cluster, and that can be deployed and managed by the Kubernetes orchestration. It's a logical application. One or more containers and volumes can be created in multiple nodes. They have shared namespaces. Now, namespaces is something that if you have under one namespace, if you have multiple pods, then just creating and removing these pods becomes super easy. You just delete the namespace, and all the pods and containers and services and deployments underneath that namespace, everything gets removed. So it's just making infrastructure quicker. And there is always one IP associated to every pod, not a node. So one node can have actually multiple pods, but you can have only one IP associated to every single pod, right? So always remember one IP address per pod. Now let's look at some of the services that Kubernetes orchestration allows. So the main thing is scaling. So automatically scaling an application. So let's say that you have this application which just says hello to everyone. So everybody goes to a URL address, and the message they see is hello. That's it. So that's a service that you're trying to do. So in order to scale that up, to go from one to multiple, in this case, I will show you how it goes from 1 to 3 replicas. It can be done just using one command. So let's say that you have a deployment, and like I'm saying that I currently have one Docker file and one Docker container, and it's just saying hello, right? So if anybody goes to a URL, and the server will say hello to them. But now I'm interested by just one Docker. I want to have multiple Dockers, so I can say hello to everyone, right? So in that case, if I just there is just one command, and I will show you that command today. As soon as that command sets in, I will say either an auto scaling, or if I'll just say this many number of replicas need to be created. What the orchestration will do is automatically it will find me 2 more nodes, and in these 2 more nodes, it will deploy these 2 hello containers, right? So now you have automatically scaled without me having to literally sit down and do any of that. But now let's say that one of the pods for some reason malfunctions. So it's not able to get an IP, it's not able to associate some hardware to it, or maybe this application was too heavy, so the amount of memory, it just ran out of memory, it's just not able to service. So node 3 for some reason, it's down, right? So if that happens, so Kubernetes orchestration by default, it will know that now it will evict that particular application from the container, and it will start a new application on some other container. So it can definitely, within node 2, it will try to create or spawn up another pod and give an IP to it, so that all these, now you have 3 copies and everybody is happy. So that's exactly what I'm talking about. Kubernetes orchestration ensures that there is a fail-safe. And this fail-safe is not something that you have to manually set in and do, but this is an automated process where you can literally see what is happening. Is a particular pod getting evicted? Is the pod functioning properly or not, right? So we are able to do all of that using Kubernetes orchestration. Now let's get into the setup that we have, so that we can all experience this outcome together. Hi, Venkatesan. So your question is discuss about PyTorch library from your experience. Okay. Any experiment planned on 3D semantic segmentation? Yes, the answer is yes. So I have actually been working on 3D semantic segmentation for the past week, and it is on medical images per se. But for next week, I actually plan to create a short video. It's not going to be a part of the live stream. I can actually show you the demo. But it was actually OCT images, and OCT images underlying pathology. It was called MACTEL, macular telangiectasia. What I had to do is, in order to segment the region of interest, and then come up with the ONFOS. And ONFOS is where you combine these layer informations together, and then you can see what the depth actually is in the 3rd dimension. So I will show you exactly how those steps proceeded, and how I was able to create that ONFOS, right? So that will be next week. So stay tuned. Thank you. All right, let's get into the demo right now. Okay, so let me share screen. All right. So the first thing is I am in GCP, and in GCP I'm actually inside a virtual machine. I'm hoping you all can see it here. I cannot blow it up a little more because I have some commands that I'm having to actually run. So these are the commands that I will be running in order to install. So first of all, whenever you are in a virtual machine, you should always do a sudo -s. A sudo -s makes sure that you are in the as a super user. So all these commands I'll actually be posting in the description box below, so you don't need to copy anything. And then you do an apt-get update, and then you need to install Docker and ensure that Docker is configured correctly. And then you need to install kubectl. So kubectl is the command that is going to ensure Kubernetes orchestration now happens very easily. And then you will need to generate a Docker image. So we've seen how to generate a Docker image last time. So this is just the Docker images that I have on this virtual machine. I am going to be using this one, which is called ODFast. So it's a ODFast or ODSSD. So either one of these, and you will see that their sizes and everything. As soon as you do Docker images, you are able to see their sizes. All right, so now the first step should be in order to spawn up a Kubernetes cluster. So these are the commands that I am going to be using to spawn up my Kubernetes cluster. So I just, first of all, I'm setting a zone, and then as soon as my zone is set, then it will try to create the Kubernetes cluster. In this case, I'm calling it ai-sohini. The number of nodes is 3, and the scope I'm setting it to Google APIs. right? So that is the project hosting and storage. So that's the reason why GCP is quickly able to communicate with the Docker images. And then I'm going to be getting the credentials so that I can literally work on the Kubernetes cluster. So me as a user, that I'm authenticated on the Kubernetes cluster. And then finally, I am going to be deploying it. So that's the few steps that I'm going to be performing today. And you will experience that, if you have one copy of the Kubernetes cluster, or, if you have one copy of the pod, or if you have multiple copies of the pod, you will see how the functionality actually changes. So I'm going to be automatically scaling. So this is the command to do that. So when you say auto scale, and here I'm saying that the minimum number of pods or the minimum number of copies is 2, and the maximum number of copies that my Kubernetes orchestration can support is 20. So that means I can have up to 20 pods spun up automatically based off of the need. So the minimum should be 2, the maximum should be 20, and the number should actually be based off of usage. So if minimal number of people are pinging it, it should be just 2. But if there are more people pinging it, then you should automatically try to raise that number. So that is exactly all these commands are doing. Now, in order to create a GCP cluster, of course, or Kubernetes cluster, it takes some time, but let me go and show you that if you go to the GKE, so that's a Kubernetes engine, here you will be able to see is as you are spawning up things there, you are actually seeing the Kubernetes cluster here. So you can always go and create your cluster through the UI, but I always suggest to do it on command line, because then you will know how to tear it down, and you make sure that all the applications actually go seamlessly. Okay, so you see, it is saying my cluster is now created and ready to go. So let me get back to the commands that I had. So if my Kubernetes cluster is up, now I need to get the credentials, right? So this command is going to help me get credentials so that I have authority to work on the Kubernetes, on the cluster. Yeah. All right. So all of the defaults are now done. And now I need to see what are the images on my Kubernetes cluster, right? So that's the gcloud cluster list. And you do see that ODSSD is actually a part of it. So if it was not, you would have to do a push command, right? So that's already done. Now let's just create a deployment, which is called ODSSD. Now what a deployment does is it takes a Kubernetes pod and it tries to expose it through a load balancer. You see now it's saying that that it has been created, and now I will be exposing it at port 8080. So that's the port at which my application is actually running, and it says it is now created. And also one more command that I'm going to be putting in is the auto scaling. So this is going to ensure my function automatically scales to more applications as I ping it even more, right? So let me clear the page, and here I will just do kubectl get svc. So this is going to expose the IP address at which my link is actually working. So you see that it says pending. That just means that it's trying to get the service up and running on the Kubernetes cluster, and there it is. So as soon as you get this external IP, this is all you need. So you need to copy this, and now let's go to a new web page, and I say HTTP, sorry, and this and 8080, right? And you see that I have this object detection API. You can actually, it's actually running right now. So you can actually try this out. So it's 35.233.196:8080. And now if I choose any file, let me go to some download images. Okay, I have some night images. So let me take a particular image, and if I say upload, now this is actually using SSD. So SSD is pretty fast. So this should be able to show you your object detection and your regions of interest pretty fast. So same way, I can go through multiple images, even if they're not good quality images. And if I do upload now, and the beauty is, if I take the same application and I open multiple pages, let's say for the same application, I have multiple pages. This ensures that I'm pinging the server all at the same time. So let's try that, right? So if I'm pinging the server all at the same time with multiple requests, then what happens? So let's do that. I have another image. I say upload. Again, here I have another image. I say upload. Here I have this image itself. I hit upload. Okay. So you see all these requests are going at the same time, and you see it is able to actually function with each and every one of them. It doesn't drop requests, and it's pretty accurate with the motorcycle and everything. So here, that's the reason why we now have this command to see if the scaling is happening or not, and it actually is. And then there is actually a command. If we enter that command, we will be able to see if the auto scaling is happening or not. So in order to check the background, let me enter that command. Here you see, this will tell you exactly what is happening at the back end. So if a particular pod is absolutely working fine, if the deployments are getting created correctly, you will see that the logs are getting generated. But at any point, if it's not able to get any metric, like said failed resource metric, or for some reason if a particular pod gets evicted, you will start seeing all of them in the log. So as a backend engineer, you will just be monitoring this. And there are also multiple ways of hooking this up with a monitoring system like Prometheus or Grafana gateway, so that you can literally, rather than looking at logs, you can actually see it very graphically. So that's the application for today. What we did is we took a Docker container and we put it on a Kubernetes cluster, so that we can keep reusing the same applications multiple number of times without having any downtime in our application. And customer is happy because you can have customers everywhere globally, and the number of class customers can also now grow based off of the amount of usage that you have now specified, right? So